So I'm going to be talking about a project which we are currently doing. And it's real-time contextual deblurring of surveillance footage with edge preservation. So blurry photos are annoying, especially when edges or fine details are lost. Today we'll be summarizing project that restores sharp images by using context-aware networks that preserve edges. Then walk through the most important papers that influence this field and finish what's still missing. So, I'll be starting. In one sentence, the project builds a deep multi-stage deblurring pipeline that uses contextual cues, multi-scale features, explicit edge maps, and edge-aware losses to restore these sharp images without creating ringing artifacts around the edges. We can use many methods. Practically, use a core to find encoder-decoder backbone, which will inject an edge detector branch that guides reconstruction and train using a mix of pixel, perpetual and edge localization losses so that model learns to prioritize sharp boundaries over smooth regions. So basically what we will be doing is we are trying to preserve the edges of the images and make the images more sharper for these CCTV footages especially. So the dataset training uses realistic blur sharp pairs. For that which we are mainly using is GoPro dataset, and evaluation using PSNR, which is peak signal to noise ratio, and SSIM, which is structural similarity index measure, plus visual edge matrices to show improvement of vanilla, multi-scale nets, and GAN approaches. So remaining will be continued by Aditya.
Okay, so I'll basically be talking about the references and contributions of different works which we went through during the survey. And the first one which actually came onto our purview was one on deep multi-scaling CNN, which was by Na et al., published in CDPR 2017. And this model actually sets a huge milestone on many methodologies because of the encoder-decoder model which they developed for high blur FPS dataset. Now, it sets a strong baseline for end-to-end single images, and this provides multi-scale supervision. So, to put it in monkey terms, it's basically it fixes blurry images in steps from big picture to small details, and by doing that, the results get much more sharper over time. Now, when we go to the second work, which is on scale recurrent networks, which was by Tao et al. In 2018, these researchers took the multi-step idea and made it smarter. So instead of building a huge network for every scale, they reused the same network again and again, which was a great development from the previous work. Then came the deblur GAN, which again used the encoder-decoder model. This was by Coopin et al. In 2018 again, and here they taught the network to imagine sharp images using trick from generative AI, but that is through the encoder-decoder network, and it makes results look more natural and sharper. But sometimes it guesses wrong and adds fake textures, which creates a problem if you're not careful with it. And then came blind deblurring with dark channel, which was by Pan et al. In 2016. Now this was actually much more older method, and it didn't use deep learning. Instead, it looked at natural dark areas in images to figure out how to remove blur. And it's slower, but taught us that using simpler image rules can help, and you don't have to technically always rely on high processing AI models to generate sharper images. And when we're looking at edge-aware deep image deblurring by Fu et al., these guys added small edge detector inside a model, so it pays extra attention to lines and boundaries. And we have edge-aware structure-guided CNNs, and this particular model was recommended by multitudes of papers. And these papers show that if you guide the model to follow sharpness and outlines while deblurring, you get sharper results without making the image look smooth or plasticky. Now, fast motion deblurring by Shao and Lee, which was an old school method that tries to guess the blur path and traverse it. You kind of find the direction of dissimilarity between pixels. And it's not exactly deep learning. It taught everyone that blur often follows a predictable pattern. And knowing that helps modern networks perform better. This is similar to frequency-based distribution that is done nowadays. And instead of and in Eagle Loss, which was done in 2024 paper, instead of treating every pixel equally, this method teaches the model focus on areas where edges and details matter the most. It's basically like putting an embedding model into an image, just like how embedding models vectorizes a particular word and gives importance to each word. They're kind of putting that concept into images while seeing which part of an image influences the most of the image. So this was done in the 2024 paper, and event and motion aware deblurring also was a very prominent paper in 2024 published by ECCV. This new idea uses motion sensors or event data to understand how things move while photo is being taken. And with that extra info, the model can remove complex blur and protect edges even better. And Deblur GoPro dataset in GitHub, this is actually a very important dataset which was again mentioned by my friend Niranjan over here. It lets researchers fairly compare results and build better models as it's put as a benchmark. And there are recurrent context multi-stage methods. Some models improve results by cleaning the image in several passes, and each pass uses context from the previous one to get sharper image to increase the quality. And there are other edge-aware CNNs and filtering works too. Many small papers combine edge maps, attention, and filtering to stop the model from washing out important lines. Together, they prove that paying attention to edges is key for real-world image sharpness. Niranjan will give a conclusion on the papers that we talked about.
So I'll be putting everything together. So here, modern deep learning has moved from pure multi-scale reconstruction to models that explicitly use structures, edge maps, localized gradient losses, and motion representation to protect fine details. Yet, gaps remain. First of all, robustness to real-world blur. Models trained on synthetic or limited data sets still struggle with unseen motions and depth varying blurs. So basically, still there are some data sets which struggle for converting these unseen motions, or like which is even darker or like that, or darker, or like which doesn't have much of light and depth to it. So the next is texture trade-off. Sharpening edges without inventing false textures remains hard. So basically, this is what Aditya earlier said. We can't like invent a new texture for this thing. If a texture is already there, we can't just put another to it, which may happen when using AIs. Okay. Evaluation matrices. PSNR and SSIM don't fully capture perpetual edge quality. So edge-aware matrices and human studies are needed. Next is efficiency. Many edge-aware modules have compute which is problematic for mobile deployments. And finally, expandability. How edge priors interact with GANs and perpetual losses can cause hallucination. More interpretable losses are needed. So this is all we have to say. If you like the summary and want a reference list which is in the description, or code to review a single edge-aware deblurring module, just put a comment. We will send everything else in the notes. Thanks for watching.
Thank you.
Bye.
Mari